A beginner's guide. Are you fascinated by robots and their capabilities? Do you want to build your own robot but don't know where to start? If so, you've come to the right place. In this beginner's guide, we'll take you through the basics of building your own robot from scratch. Before we dive into the details, let's first understand what a robot is. A robot is a machine that can be programmed to perform a variety of tasks. It can be controlled by a computer or operate autonomously. Robots can be found in various industries, including manufacturing, healthcare, and even space exploration. Building your own robot can be a fun and rewarding experience. Not only will you learn about robotics, but you'll also develop skills in electronics, programming, and mechanics. Thus, you'll have a robot that you can customize to your liking and use for various purposes. In this guide, we'll cover the following topics: choosing the right components for your robot, assembling the robot, programming the robot, testing and troubleshooting the robot, customizing the robot. By the end of this guide, you'll have a basic understanding of how to build your own robot and the skills to take on more advanced projects. So, let's get started. A beginner's guide. Before you start building your robot, you need to choose the right components. The components you choose will depend on the type of robot you want to build and the tasks you want it to perform. Here are some of the essential components you'll need. 1. Microcontroller. A microcontroller is the brain of your robot. It's a small computer that controls the robot's movements and actions. Some popular microcontrollers for beginners include Arduino and Raspberry Pi. 2. Motors. Motors are used to move the robot. You'll need different types of motors depending on the type of movement you want your robot to have. For example, you'll need DC motors for wheels and servos for arms. 3. Sensors. Sensors are used to detect the environment around a robot. You'll need sensors like ultrasonic sensors, infrared sensors, and light sensors to help your robot navigate and interact with its surroundings. 4. Power supply. Your robot will need a power supply to operate. You can use batteries or a power supply unit PSU to power your robot. 5. Chassis. The chassis is the body of your robot. You can buy a pre-made chassis or create your own using materials like plastic, metal, or wood. Once you have all the components, you'll need to assemble them. You can use a breadboard or a PCB printed circuit board to connect the components together. Choosing the right components is crucial to building a successful robot. Make sure you research and choose components that are compatible with each other and fit your budget. In the next segment, we'll cover how to assemble your robot. A beginner's guide. Now that you have all the components, it's time to assemble your robot. Assembling your robot can be a challenging task, but with the right tools and instructions, it can be a fun and rewarding experience. Here are the steps to assemble your robot. 1. Plan your robot. Before you start assembling your robot, you need to plan it out. Decide on the design, layout, and placement of the components. This will help you avoid any mistakes and make the assembly process smoother. 2. Build the chassis. If you're building your own chassis, start by cutting the materials to the desired size and shape. Then, drill holes for the components and attach them to the chassis. 3. Connect the components. Use a breadboard or PCB to connect the components together. Follow the wiring diagram and make sure all the connections are secure. 4. Install the software. Once the components are connected, you'll need to install the software on the microcontroller. This will allow you to program the robot and control its movement. 5. Test the robot. Before you start using your robot, test it to make sure everything is working correctly. Check the movements, sensors, and software to ensure they are functioning as expected. Assembling your robot can take some time, but is an essential step in building a successful robot. Make sure you take your time and follow the instructions carefully. In the next segment, we'll cover how to program your robot. A beginner's guide. Programming your robot is an essential step in building a successful robot. It allows you to control the robot's movements and actions and make it perform the tasks you want it to. Here are the steps to program your robot. 1. Choose a programming language. There are several programming languages you can use to program your robot, including C++, Python, and Java. Choose a language that you're comfortable with and that's compatible with your microcontroller. 2. Write the code. Once you've chosen a programming language, it's time to write the code. Start by creating a basic program that controls the robot's movements. Then, add more complex commands and functions to make the robot perform specific tasks. 3. Test the code. After you've written the code, test it to make sure it's working correctly. Use a debugger to identify any errors or bugs in the code and fix them. 4. Upload the code. Once the code is working correctly, upload it to the microcontroller. This will allow you to control the robot's movements and actions. 5. Refine the code. As you use the robot, you may need to refine the code to make it more efficient or add new features. Make sure you document any changes you make to the code. Programming your robot can be a challenging task, but with practice and patience, you can become proficient in programming robots. In the next segment, we'll cover how to test and troubleshoot your robot. A beginner's guide. Testing and troubleshooting your robot is an essential step in building a successful robot. It allows you to identify any issues with the robot and fix them before they become more significant problems. Here are the steps to test and troubleshoot your robot. 1. Test the movements. Start by testing the robot's movements. Make sure it can move forward, backward, left, and right. Check the speed and accuracy of the movements. 2. Test the sensors. Next, test the sensors. Make sure they're detecting the environment around the robot correctly. Check the range and accuracy of the sensors. 3. Test the software. Test the software to make sure it's controlling the robot's movements and actions correctly. Check for any errors or bugs in the code. 4. Troubleshoot any issues. If you encounter any issues with the robot, troubleshoot them. Use the debugger to identify the problem and fix it. Check the wiring, components, and software to ensure they're working correctly. 5. Refine the robot. As you test and troubleshoot the robot, you may need to refine it. Make any necessary changes to the components, wiring, or software to improve the robot's performance. Testing and troubleshooting your robot can be a time-consuming process, but it's essential to building a successful robot. Make sure you take your time and thoroughly test the robot before using it. Congratulations! You've now learned the basics of building your own robot. With practice and patience, you can take on more advanced projects and create robots that can perform complex tasks.